Well, welcome to lesson 13. In this lesson, we're going to go over a couple new features that were recently added to Easel. The first feature has to do with the tool paths and where you start. Up to now, the only place you could start was the bottom left corner of the board. And set that to XY0. They added a new feature which now lets you center it. So let's demonstrate that. I'll bring up a box and we'll just put this in the middle somewhere. Change the cut a little bit so it goes a little faster. There we go. So we're going to cut a box like that. Now, when I generate a toolpath, you notice it starts from the bottom left corner. Let me bring this back to 0, and I'll start it slowly. Notice it starts from the bottom left corner and then works its way around to cut this particular indentation in the wood. All right. But one thing we can do to change it. So let's bring it back here. And we'll go up and look at this birch plywood drop down, I'll call it, or the wood drop down. And where you change the size, you can change the width and length and thickness of the wood, enable tiling. But they've added this new feature here, which is front left corner, it says, and you could do center. Now look what happens when we do a simulate. It's going to simulate quickly, but you can see already that's different. And look at, you can see that they're demonstrating this, I guess it's supposed to represent a router bit in the center there that will begin to carve if you watch it. And it's working its way around. So in this case, we would set X, Y, and 0 right into the center of our material. And that's pretty helpful if you have a piece of, let's say, you're engraving something in a slab from a tree, and you have live edge on it, and it has an irregular shape. You'd certainly want to start in the middle, since you really don't have a true XY lower left corner to work with. You probably want to start in the middle somewhere. So this is very helpful. And there was a workaround that I think we demonstrated in a previous lesson, but this is a lot cleaner. And as you notice, when we use it, the whole object appears in the wood where we expect it to. All right, let me Control Z back out of all this, and we'll start over. And now we're going to do the second feature. The second feature has to do with three-dimensional cutting. And if you look on our our project menu, there's something new added there. It says import 3D STL. And there's another box on the left menu here which says the same thing, import 3D STL. All right, an STL file. Let me explain what an STL file is. STL files, let me bring one up. Where did I leave that? It's on the desktop. You can see, here it is here. I'm going to bring this in. Now, an STL file, well, I'm opening this up. It's validating the file. Let's take a look and make sure the STL file has the features that it's looking for. An STL file is basically goes back to the late 1980s. A company came up with this file format, and their focus was stereolithography. So what they were doing is looking at three-dimensional representations of an object. And they came up with this format called STL. And STL is nothing more than a bunch of triangles. And there's thousands and thousands of them in every image. And you just put them together to create this shape that we have here in this case. And there's a limit, a file size limit on this, and I don't recall what it is right now, but it's pretty large. The problem you have with STL files, if you get too large, which means they have too much detail or they're too big, the cut time or the time to move the bit around and create the features that you want could be in a matter of days, not hours even. So you want to be careful with the size of your STL files. All right, this one came in. If you look at it, the orientation says top up here, but in this particular case, we want the front. All right. And also, if you look at the position there in this box here, we could just hit center to the material, and it'll fit right in there. Now my material was set to 13 by 9, so there's plenty of room within in that if we leave it like it is even. However, I'm going to make it smaller. If you look down here, this is the size of the object that came in. And you really don't have any control over that when you bring it in, since STL files don't truly have dimensions like as we're familiar with. So this came in and assigned these dimensions to it. But we can change that. And if you click on Lock XY here, and the little lock blue button comes up, what that does is make sure you maintain the same X to Y ratio. In other words, when I change X, in this case I'm going to change X to 4, you notice Y will change to something approximating what it was before. And I'm going to send it to the material again. All right. So now I have a much smaller object that I'm going to do. But let's take a look at something else. I'm going to move this with my mouse. And if you look at it, you can see that actually it is a box now, a three-dimensional box. And that's what we wanted. So this is going to be cut within a three-dimensional block of wood in our case. But let's look at one other thing. My wood is a 1/2 inch thick. This object that we're trying to create, according to the z-axis here, is more than 0.5 inches. It's 0.56. So you really couldn't. You'll be actually cutting through the entire piece of wood to cut this. So I'm going to make this a little smaller. I'll make it 0.2 inches. You'll still maintain the same features, but you won't be cutting as deeply into the wood. And there's something down here, full depth cutout with auto tabs. Yeah, we're going to cut the whole thing out and we're going to put tabs on it. And we can also decide down here to generate our cut in a certain direction. So if we had grain that was going across this piece of wood, we would maybe want to use this one. If we oriented our grain in this direction from bottom to top, we might want to change it to along the y-axis. And the purpose of that is just to reduce splintering. All right, so now we're set up to go. If you look down here at the estimated time, and this is kind of important, there's always a roughing pass associated with this. And quite frankly, most of the time we're going to be using a 1/4 inch straight bit to do this. There's a lot of material that needs to be taken off. If you think about the object that we created, the Z, or the height of the carving, may be below the height of the wood. So you have to take a lot of material off to get to the highest point on your carving. So you really want to start off with a roughing pass and use a fairly large bit. And so pretty much our standard will be a 1/4 inch bit. Now, the second bit we're going to use is a finishing bit. And we're going to always use a bullnose. And the reason we're going to use a bullnose is that we have to be able to carve these features. And a lot of them have rounded edges, etc. So we can't really do that with a flat bit. So this bullnose, and we do have some at the shop, would be the go-to bit for this particular project. So let's look at one other thing, the cut settings. This is automatic settings. If you look at this, in the roughing pass, they say the step over is 40%, and this is something we need to be aware of. What that means is when we plunge down into it and make our second cut, we're going to move over 40% of the width of the bit. So less than half of the width of the bit, and we're going to work our way over. On the finishing pass, if you notice this, and this is our bullnose bit now, it's only a 10% step over. That's a fairly low step over, and that'll maintain a lot of detail for us. Now, if you put these in manual mode, I can do one or both of them in manual mode, and I can make this roughing pass, let's say a 60% step over, because really it's not you're not gonna affect your detail much with that. But this one we're going to change to about 40% step over. When we do that, when I look down here at the roughing estimate, it's still around less than 10 minutes, but now the finishing estimate is also less than 10 minutes. If I move it back to 10%, you'll see that the finishing is closer to an hour. So what that happens is we're going to lose a little detail in our carving by increasing the step over. However, does it really matter? Well, it depends upon the carving that you're doing. So a little experimentation there, but I think we'll find that we want to keep the machine time down a little bit. Maybe 40% is too much. We could go to 30 or 20%, but we'll have to experiment a little bit with that. So let's run our generate our tool paths now. And remember, it says it's going to use tabs. We're going to generate the tool paths. And it's going to generate them, in this case, from the bottom left corner. I have found out that our tool paths will not center, and that feature that we just spoke about, where we can start our path in the middle, does not seem to work with the 3D model. So for now, at least, we'll have to go from the bottom left corner, and hopefully they'll be able to fix that over time. All right, but if we look at this, let's go back and bring this to the start, and now it's going to show the finishing. Let's say, oh no, we want to start it, and it's going to start our tool paths. And you can see it's going to start cutting out, and we could speed that up quite a bit and see what it does. You can see it's taking over. It actually is cutting way into the wood with the roughing pass, and then with the finish pass, it's doing the detail. So let's show the preview. At this point, it's going to show you what it looks like in there. Now, of course, we have to get rid of all the tool paths to see what it actually did, but there it is. There's our feature that we were trying to carve. And if you look down in it, let's spin it around a little bit here. It doesn't show the tabs, but we left tabs in there. I think this up here is a tab, but we'll go back to the cut setting. Oh, excuse me, to the. I don't remember where it was. Somewhere in here there was some place to put tabs, but I don't recall what it is. All right, whatever. Okay, but anyway, there were tabs appearing somewhere when we started this. So this should work out with tabs, and we'll create a cutout that looks like this. And the thickness of this bottom board, I'm going to guess, is, since our board is half-inch thick, and we said that our features are going to be 0.2 inches thick, that there's going to be maybe a quarter of an inch or more of board left here. And then, of course, it was cut out after we cut that out. All right, so we'll see what happens with that. So we'll give that a try, and we'll give you an update on this when we can. All right, so that's the new features that came up this week in Easel, and hopefully they'll allow us to be more creative in our projects. Thank you.